So, last Monday of the semester. So you've got Monday, then Wednesday, then Friday, and that's it. So 3 more class periods of lectures to watch and whatnot. All right, so remember, we're in the chapter on pH. So in case you took the break off and you didn't do anything, let's refresh where we're at. So we're talking about pH, so acids, bases, pH, pOH, all that. So this problem we did last class, we talked about how to solve the Ka, and if you need to solve the Ka, that's an equilibrium. And so I need to know what the equilibrium concentrations are. And so I have to do an ICE table. All right, now let's do the next problem. So let's read the problem. It says determine the pH of a 0.1 molar propionic acid, C2H5COOH solution at 25 degrees Celsius. The Ka is 1.4 times 10 to the negative 5. And it says what percent of acid is ionized? All right, so let's do our steps like always. What am I looking for? So I want the pH, okay? And then what did they give me? So they gave me the concentration of my acid. It's 0.10 molar, and we're just gonna say propionic acid. You can just shorten it, it's fine. Temperature, Ka. Oh, I missed this. They also want to know the percent ionized. My bad. So they want to know the pH and the percent ionized. And then they want we have the concentration, the temperature, and the Ka. I'm getting rusty. I haven't taught in a while. Plus, I miss having you guys here answering all my questions. Not the same. Okay. So, I'm looking for the pH. That's the first thing we want to figure out. So if I'm looking for the pH, your thought might be like, oh, okay, well let me just do this. pH is equal to negative log of my H plus concentration. And if this is an acid, then I can just use this, right? And just plug that number into here and go from there. Assuming that it produced only one H plus. It was a 1-to-1 ratio. So you might be thinking, that's what I can do. Now, this is why I put this problem in there. I can do that only if this is a strong acid. So the only time you can directly do these problems is if they're strong. So we did like back here, when we just directly found the pOH, these were strong bases. So the only time that you can just directly plug it in is if it's strong, okay? Now, if they give you like the H plus or the OH minus concentration, that's different. But just to plug in the concentration like this, assuming it's a 1-to-1 or a 1-to-2 ratio, that's assuming these guys are strong. Okay, so I have to figure out, okay, can I just plug this in or not? So I need to know, is this guy strong or is he weak? Oh, now he won't let me erase. There we go. Okay, I was like, why can't I erase? So, you have your chart that's at the beginning of this chapter of your strong and your weak. So first you want to figure out, is this guy on your chart? So if you were to go back and look at your chart, and let me flip there in my notes real quick. I'm almost positive it's not on the chart, correct? Yeah, it's not on the chart. So if it's not on the chart, you can assume it's weak because there's only so many strong acids and bases. So we're telling you who's strong, and then we're telling you the common weak guys, but there's a lot of other weak acids and bases. So if it's not on the chart and it's not listed as strong, or if I don't tell you it's strong or something in the problem, then you go ahead and you assume it's weak. So we go, okay, so this is a weak acid. So I can't just directly plug it in. So if it's a weak acid, then the way that I'm going to end up finding the pH is I can't just plug in this number into there. I actually have to know, okay, well, how much is it actually going to dissociate? Because remember, weak acids don't completely dissociate. So if I have my acid, this is my acid, doesn't matter. We don't have to get the formulas exactly right. Okay, so just say propionic acid plus water. Just be generic. It's going to go, because this is an acid, he's going to give up his H plus to go to him, so he'd be H3O plus, and he would be just minus, and minus an H. But we could just be generic. If you want to know the exact one, because you're curious, it's this guy, and then But I don't want you to spend a bunch of time trying to write those because it doesn't actually really, you don't have to actually have the exact equations to do these. So remember when we said they're weak, you get this double-headed arrow. So that means that not all of this goes to here. So even if it's a 1-to-1, it doesn't mean that if this is 0.1 molar, this is also going to be 0.1 because it's a weak acid. If it's a strong acid, then it is, and that's why we could use the pH equation. But since it's weak, I have to figure out how much of this is actually made. So to figure out how much is actually made, what do I have to do? An ice table, okay? So I need to do an ice table. All right, so let's figure out, what did I start with? I started off with my acid, so this is my 0.1. Just like in the Ka equation, this is a liquid. Liquids aren't included, so we don't include them in the ice table. This is 0, this is 0. It's all 1-to-1 to 1-to-1. The ice tables for acids and bases are simpler because it's always 1-to-1. So this is just going to be minus x plus x plus x. So 0.1 minus x, and then x, okay? So now let's write my Ka. So my Ka formula should be my H3O plus times my acid ion over my acid whole, okay? Because water is a liquid, we don't include it. I know my Ka because they gave it to me. So 1.4 times 10 to the negative 5 is equal to, this is an x, this is an x, and this is 0.1 minus x. Now, the top will be x squared, but the bottom won't be. And so what happens is, with all acid or bases, they automatically require the quadratic equation. But we don't want to do the quadratic equation every single time. So we want to have a way where we can kind of approximate. So I'm going to teach you the approximation method of how to do this. So it's going to give you an approximation of the pH, which is close enough for what we're doing. All right, so I'm just going to rewrite this. So we had 1.4 times 10 to the negative 5 is equal to, we'll go ahead and do that, x squared, 0.1 minus x. All right, so what we want to do is we want to be able to approximate. So to do the approximation, there's a few criteria we need. If x is a lot less than 0.1, that's good. We don't know that until we solve it. So that one we don't know yet. Ka is very small. And my percent ionization is less than 10%. Those are my criterion. If I meet these criterion, I can then ignore this x, which simplifies my work a lot. Okay? Now let's look at the first thing. The first thing is the x. Can't do that yet. The Ka, so I can look. Here's the Ka, 1.4 times 10 to the negative 5. That's pretty small. So we're good there. So check. Percent ionization. I don't know that yet. That's actually part of my things I'm looking for. It says percent ionized. So I'm going to end up looking for that. So sometimes we have to just kind of hope we can do the approximation, go ahead and do it, and then go back and make sure, oh yeah, it was good. We could have done it. So sometimes you just have to go with it and then hope it was okay that you went with it. So we're going to go with the approximation, and then we'll make sure it was okay later. So we get rid of the bottom x. Okay? Multiply the 0.1 over, you get 1.4 times 10 to the negative 6 is equal to x squared. Square root both sides, and x is 0.00118 molar. So now we can do our second check of our approximation. This said x must be a lot less, way less than 0.1. This is a lot less than 0.1. So that matches. So we get that check for our approximation. So now that we have x, what were we trying to find? The whole point of this problem, whoops, didn't mean to do that. The whole point of this problem was to find pH. pH is negative log of the hydronium, so I needed the H3O+. The H3O+ is just x. So if I know x, I know H3O+, so now I can solve. Okay? So pH is negative log of the H3O plus. We said X was equal to the H3O plus from my ice table. So that means I could just plug it in. Negative log of 0.0118. So that gives me a pH of 2.93. All right, so I got the first part done. So the first part was wanting the pH. The second part, so I got the pH, now I need the percent ionized, okay? So here's how I do the percent ionized. So percent ionized is X over initial. So X over initial times 100. So in my problem, my X was right here, 0.00118, and the initials, how much did you start with? You started with 0.1. So that's my initial times 100. And that gives me a percent ionized of 1.18%. And our third criteria was that it had to be less than 10. So I meet all my criteria, so now I'm like really confident and I go, yep, these two are my final answers. Now I have my pH and I have my percent ionized. Okay, so if they ask you to find the pH and the percent ionized, sometimes they won't ask you directly the percent ionized because they assume you're gonna just solve it indirectly in the problem. So it might just ask pH. Okay? If they ask you the pH, you have to figure out if it's weak or strong. If it's strong, then it's super quick. Just plug into the pH equation. But if it's weak, you have to do an ice table. Okay? So there's your ice table, there's pH. So now we're going to talk about base ionization constants in the next video.